Good day. Today we're going to discuss some introduction to statistics. So we have here population versus sample. The concept of population and sample was then introduced to you in your basic education. So let's try to recall the concept of the population and the sample. Here is the illustration of the population and a sample. Now, if you can recall, when we say population, it is the totality of all the subjects possessing certain common characteristics that are being studied. And within the population, you have here the sample, which is a group of subjects selected from the population. So, in other words, the sample becomes the representative of the population. Here in our illustration, the stars represent the case or the element within the population. Now, when we say population, it does not necessarily mean a number of people. It is a collected term used to describe the total quantity of things of the type which are the subject of your study. So, a population can consist of certain types of objects, organization, people, or events. So when we say population, it is not inclusive or it is not pertaining only to a group of people, but it could be events, organization, and all. Okay, now why we need to sample? Now, the process of getting a sample is called sampling technique. So, if we are going to get a sample from the population, the process of getting that sample is called sampling. So, sampling is a valid alternative to a census when one, the survey of the entire population is impracticable. We have budget constraints, restrict data collection. We also have the time constraints, which restricts the data collection, and the result from the data collection are needed quickly. So, if the data you collect really um are the same as you would get from the rest of the population, then you can draw conclusions from those answers which can be related to the whole group. So that's the essence why we need to sample. Okay, now let's have sampling method. So what would be the kinds of sampling techniques? Okay, when we are in our basic education or even in our college, we encountered the sampling techniques. So these are the sampling methods, okay? And as we can see here, there are two types of sampling methods or sampling technique. The first one is the what we call as the probability sampling method, and the second one is the what we call as the non-probability sampling methods. Within the probability sampling methods, we have simple random sampling, we have the cluster sampling, we have the systematic sampling, and the stratified sampling, or the stratified random sampling. In the non-probability sampling, we have the convenience sampling, the purposive sampling, the snowball sampling, and the quota sampling. Now, when we are talking about probability sampling is a technique that gives the most reliable representation of the whole population. It is the sampling technique in which sample from the larger population are chosen using a method based on the theory of probability. That's why it's called probability sampling. For a participant or a respondent to be considered as a probability sample, that person must be selected using a random selection. The most important requirement of probability sampling is that everyone in your population has a known and an equal chance. So when we say an equal chance, it's not UN, but it is AN. There should be equal chances, and then there should be a, a standard that is known on getting the sample. So the probability sample uses statistical theory to select randomly a small group of people, which is called the sample, from an existing large population, and then predict that all their responses together will match the overall population. So that's what we call as probability sampling method. So what is the essence there, or what would be the key word there, is that the probability sampling should have all the all the population must have equal chances of getting selected. So that's why we have that's why it's called probability sampling. So there should be a statistical theory on how to select randomly your sample. Now here, the first sampling method, the first probability sampling method under the uh, we have here the simple random sampling. So this one, simple random sampling. Now, when we say simple random sampling, it is a as as the name suggested, it is a completely random method of selecting the sample. This sampling method is as easy as assigning numbers to the individuals or the sample and then randomly choosing from those numbers through an automated process. Okay, because today we are using technology, and then, for example, in your population you have 1,000, and each person within the population should have a corresponding numbers, and then you let the technology, let's say the Excel, okay, to choose a number, and then whatever the number being chosen by the Excel, then that person uh, holding that number would be selected as your sample. Okay. Now another is the what we call as the cluster random sampling. So in the cluster random sampling, it is a way to randomly select participants or respondents when they are geographically spread out. Now take note, the keyword here should be geographically spread out. Cluster sampling usually analyze a particular population in which the sample consists of more than a few elements. For example, we have the location, which is the city, or we could have the family, or we could have the school. Okay, so the clusters are then selected by dividing the greater population into various small sections. So that's what we call as the cluster sampling. Now, when we say systematic sampling, it is when when you chose every nth term or nth individual to be part of the sample. So, for example, if you chose every fifth people in to be the sample. Now, if we go back to the example of the simple random sampling, as what I had suggested, for example, if you have there 1,000 persons within the population, and each person has a corresponding number. Now, since a corresponding number from 1 to 1,000. Now, For example, you are saying that for every fifth person in that particular population, that person, the fifth person, becomes the member of your sample. So that's what we call as systematic sampling. So systematic sampling is an extended implementation of the same old probability technique, which is the simple random sampling, in which each member of the group is selected at regular periods to form a sample. There is there is equal opportunity for every member of the population to be selected using this simple sampling technique. Now, another is the what we call the stratified random sampling. Stratified random sampling involves a method where a larger population can be divided into smaller groups, which is called the strata. That is, usually don't overlap but represent the entire population together. While sampling these groups can be organized and then draw a sample from each group separately. A common method is to arrange or classify according to sex, according to age or ethnicity. Okay, then from those groups, you are going to get a sample that represents each strata. Okay, now uh, let's have a concrete example. So, for example, in a school, it has 80 permanent full time teachers, and then you also have 20 provisionary teachers. To draw a sample of 50 teachers, because there are 100 teachers in the school, a simple random sample of 40 full-time teachers is selected, and a simple random sample of 10 provisionary is selected to form a 50 teachers. So that is an example of stratified random sampling. Now, in the other hand, we have the non-probability sampling techniques. So these techniques relying on the judgment of the researcher or on accident cannot be generally uh, cannot generally be used to make generalization about the whole population. So that's the difference between the uh, probability sampling method and non-probability sampling methods. Now we have here the convenience sampling. When we say convenience sampling, it is a non-probability sampling technique used to create a simple as simple as ease of access, okay, or readiness to be part of the sample, or availability at a given time slot, or any other practical specification of a particular element. So, in other words, convenience sampling involves selecting haphazardly those cases that are easiest to obtain for your sample, such as person interviewed it at a random, let's say, random shopping center for a certain product. Okay, so that's what we call as convenience sampling. So from the word itself, convenience, there is ease of access. So that's why it's called convenience sampling. Another is the what we call as the judgmental sampling, or also known as purposive sampling. So this in this process, the sample members are chosen only on the basis of the researcher's knowledge and judgment. So, in other words, it enables the researcher to select cases that will best enable him or her to answer the research questions and to meet the objectives set in your study. So that's why it's called judgmental, because the process of selecting the process of selecting your samples is based on your judgment, based on the purpose. So that's why it is purposive sampling. Another is the what we called as the snowball sampling. When we say snowball sampling, it is a method purely based on referrals. And that is how a researcher is able to generate a sample. Take note, there is a referral. So this method, okay, can be, or at some in some references, this method is called the chain referral sampling method. This sampling technique can go on and on, just like a snowball, increasing in size until the time the researcher has enough data to analyze, to draw conclusive results that can help the school or the organization make informed decisions. That's why it's called snowball sampling. Remember, although we are not in the winter country, the snowball, if you form a ball out of snow and then you let it roll in the field with snow, as you roll it over and over again, okay, the snow increases its size. So that's why it's a snowball. If we are going to have an analogy of that to the sampling methods, so there is a referral. So for example, you get a person being your sample. Okay, you interviewed or you get the data of that person, and then you ask that person to give two to other to another two members or another two persons that that person knows. Okay, so that's why it's referral. Okay, another is the what we called as the quota sampling. So the selection of members in this sampling technique happens on basis of preset standards. So not there should be a preset standards. In this case, as a sample is formed on basis of specific attributes, the created sample will have the same attributes that are found in the total population. It is an extremely quick method of collecting samples. So, in other words, quota sampling is a type of stratified sample in which selection of cases within the strata is entirely non-random. Now, take note, when we go back to stratified random sampling, okay, you group them, or you make a strata out from a category, let's say religion. Now, in the stratified random sampling, the stratified the okay, from each group or the strata, you will have a sample, but the sample should be using simple random sampling. However, in the quota sampling, there is no random sampling happen that you are going to choose within the strata, but you are going to set standards, and then whoever satisfies the standards that you have set, then he or she becomes the member of the sample. So that's the difference between the quota and the stratified. Okay, you already have now the process on how to gather the data out from your sample. Now, what are the types of data that you are going to gather? So let's have the types of variable. In the types of variables, we have this one according to row 3 in 2000. Okay, so the variables are now then divided into two. You have the category and the quantity. In the category, it is then divided into two. You have the nominal and ordinal. However, in the nominal and ordinal, they shared two types of data. You have there, the nominal can be divided into binary and non-binary, as well as the ordinal can be divided into binary and non-binary. However, in the quantity, you only have two divisions there. It could be discrete or continuous. Now, when we are talking about categorical data, categorical data or the category, okay, are the objects, okay, the objects being studied here are grouped into categories based on some qualitative traits. Take note, the basis for the groupings in the categorical data is based on some qualitative traits. So the results or the resulting data are merely labels or categories. So the keyword here is label or the categories. So when you label a certain group or you are labeling the as the persons based on their traits. For example, eye color. Okay, for example, you have a student who has a blue colors in their eyes, or brown, or hazel, or green. So uh you categorize them according to qualitative traits. So that's categorical because you are just labeling them. Okay, and then another example, newspaper. You could have the Sunstar, the Philippine Inquirer, the Mindanao Times. What else? The Manila Bulletin or the Telegraph, diba? So those are examples of categorical data. Now, the categorical data is then divided into two, as you can see in the concept map. The nominal, okay, here we have the nominal. So, a type of categorical data in which the objects falls into unordered categories. So, in other words, when we say nominal, the order is disregarded. So, for example, you have type of bicycle. So, the type of bicycle, we could have the mountain bike, the road bike, the chopper, or the folding, or the BMX. So, each type of bicycles, okay, there is no order there. The ranking is unimportant. So that's why it's called nominal. So for example, you nominate a number, okay, in each type of bicycle. Let's say one for mountain bike, two for road bike, or three for chopper, something like that. So from the root word nominate. So that's what you call as nominal data. Say another example, you have the cultural communities like Dibabawon, Tausug, Ilocano, Mandaya, etc. Okay, so you nominate a number to represent the Dibabawon. You another let's say one for Dibabawon, two for Tausug, three for Ilocano, let's say four for Mandaya. The numbers one, two, three, four there doesn't possess the concept of order. Okay, the one there doesn't mean that he is number one or he's the least. The number there is just a label, but their their qualities are uh, it seems that they are equal in value. Okay, so it doesn't mean that the Dibabawon is number one, they are the first one, something like that. So the number there is just a label. Okay, now we also have here ordinal. So in this type of data, okay, or categorical data, the order is important. So when we are going to compare nominal and ordinal, nominal, the order is not important. But in ordinal, the order is important. So let's say first class, second class, or first honor, second honor, or degree of illness. Let's say none, you have mild, the moderate, acute, chronic. So these are ordinal because the order is important. Now, the nominal and ordinal can be classified as binary or non-binary. Now, when we say binary, it is a type of categorical data in which there are only two categories. So, the data can be there are no other data. There are no other data, but you only have two. For example, smoking status. You have the smoker, the non-smoker. So anyone who smoke are the smoker, and anyone who don't smoke, then they are non-smoker. Another, we could have attendance. We have the present and the absent, or class mark. We have pass, fail. Okay, so those are binary. Okay, now on the other hand, as we can see here, we have the quantity. So when we say quantity, the objects being studied are measured based on some quantitative traits. So category is based on qualitative, while the quantity based on quantitative traits. The resulting data are set of numbers. Okay, so for example, you have the pulse rate, the height, the age, the exam mark, the size of the bicycle frame, the time to complete a statistics test, or the number of cigarette smokes. So those are quantitative traits. Okay. Now the quantitative or the quantity variable can be divided into two. You have the discrete and the continuous. When we say discrete, it implies counting. So the data here can be gathered by counting. So, example, number of children in the family, or the number of students passing the examination, or the number of crimes reported to the police station, or the number of bicycles sold in a day. So, generally, discrete data are counts. We would not expect to find 2.2 children in the family, di ba? So, you could not say 2.2, or 88.5 students passed the examination, or you could not also say 127.2 crimes being reported to the police station, or half of a bicycle being sold in one day, di ba? So that's why it's called discrete, because you can only obtain it by counting. in other in the other hand, we have continuous. So theoretically, uh, the continuous data can be gathered using a measuring device. Okay, so that's continuous data. For example, you have the size of the bicycle frame. So you are going to use a measuring scale to determine the size of the bicycle. The height, we can determine the height using measuring devices like ruler, tape measure, or scale tape, something like that. You could also have the time. Okay, the time to finish the 500 meters run, diba? So that's continuous. Or it continuous also. Uh, Age is also an example of continuous data, because you are going to use calendar to measure the age. So generally, continuous data come from measurement. So that is the difference between continuous and discrete. So discrete, discrete counting. Continuous, you should use a measuring device. Okay. Now, in the quantitative data, okay, there are two variables that are not in the uh, concept map. We have the interval and the variable uh, inter uh, interval variable and the ratio variables. Okay. Now, when these two variables, usually they are interchangeably but incorrectly used by social scientists. Take note, we teachers are called social scientists because we study learners. Okay, and learners are social. Okay, that's why we teachers are called social scientists. Okay, now when we say interval, okay, ordered categories, no inherent concept of zero. So we can calculate a meaningful distance between categories. Few real examples of interval variables are so in social sciences rather. So take note that when we say interval, there is no real concept of zeros. For example, temperature. When you say 0 Fahrenheit, it doesn't mean that there is no temperature at all. It's just it it's just zero. But the zero there does not uh, implies that there is no temperature. It could be negative 70 degrees Fahrenheit, or what's the conversion? I forgot. Okay. Now, another is IQ test. Okay, so if a person receives zero in the IQ, it doesn't mean that that person has no intelligence at all, 'di ba? Okay, and take note that when a person has 120 IQ, it does not imply that that person is twice as intelligent to the person who receives 60 IQ rating. So it doesn't mean that that 120 IQ is as twice as intelligent as 60. So uh, the main concern here is that there are some researches or researcher that uh, could raise this problem. For example, can we assume that the attitudinal data represents real quantifiable measured categories? For example, very happy is twice as happy, or the very unhappy means no happiness at all. Okay, in that aspect, statisticians are not in agreement to that concept. That's why Likert scales, okay, there are some statisticians do not use Likert scales, or there are some researchers do not use Likert scales because up to this moment, okay, the concept of the Likert scales are in not in dispute, but there is a Waterloo or a gray aspect of that concept, the Likert scale. Okay, okay, let's move to ratio. In this case, the ratio has a true meaningful zero. Okay, possible to calculate ratios. So also has the interval property. So you have there someone earning 20,000 earns twice as much as someone who earns 10,000. So when we say uh, ratio, an example for this is, let's say, okay, as we can see here, the income. Okay, the distance between any two adjacent units in the measurements or the intervals is the same as there is a meaningful 0 point. Okay, what does it mean? It means that for example here you have a person earning 20,000, that person earns twice as much as someone who earns 10,000. Okay. Another example there is the height. Okay, the height, there is a true meaning of zero. So if the increase of the height is zero, it means there's no increase at all. Okay. Another is the unemployment rate. So it measures as the numbers of job seekers as percentage of the labor force. So let's say when say the employment rate is zero, so there's no increase at all. Or the employment rate is negative, it means there is a negative increase, decrease rather. There is a decrease in the uh, unemployment rate. Okay. However, the difference between interval and ratio usually do not matter, or it's not important for statistical analysis. So uh, that's the cue there. Okay, interval and ratios do not matter in statistical analysis because they are all under the uh, quantity variable. Okay, so it is important to know the types of data, the types of variable. So the type of data collected in the study determine the type of statistical analysis to be used. So that's why it is important to understand why we need to have to understand the type of data.